So we have our piecewise functions. The definition of a piecewise function is a function that's usually defined by more than one formula. Each of these formulas will have their own interval known as their domain. So for example, this piecewise function right here is contained of three functions. You have a quadratic, a point, and a linear equation. The steps to graph each of these functions are as follows. Step 1 is I want you to set up a t-table for each function separately. Then you need to find the x values, which are known as the domain. These are going to come from the interval given in the problem. Use the numbers that fit within the inequality and start with the number in the inequality. Then you need to find the y values known as your range by plugging in the x values into the function. Once when you have all these points set up, you need to figure out which of these is going to have an open or closed circle based on the interval. Then you graph each of these separately. So let's look at our first function. We have f of x equals x minus 4 when x is less than 2, and equals 1 when x is greater or equal to 2. So technically we have two functions right here. So go ahead and start creating your two t-tables. Now the first one we're going to do for the x minus 4 when all the values are x is less than 2. So we're going to start with 2 and then we're going to do less than, so 1, 0. About 3 points should be sufficient for these. Then we just plug these values into our equation. So 2 minus 4 gives us a negative 2, 1 minus 4 gives us a negative 3, and then 0 minus 4 gives us a negative 4. Now, since x is less than 2, it's an open circle, closed, closed. These will help us figure out what the points of how we graph them and when we get to domain and range. Now on this one, x is greater or equal to 2. So we're going to start with 2, 3, and 4 because we want all the values that are greater than 2. Now technically there's no x value for us to plug these in because y equals 1. So we're going to say 1, 1, and 1. Now since it's greater than or equal to 2, we have a closed circle, closed, and closed as well. So then we just need to graph these. We have 2, negative 2, we have an open circle, 1, negative 3, closed, 0, negative 4, closed. So all the values are from 2 and less than, so we're just connect the dots. Then we have 2, 1, closed circle, 3, 1, closed, and closed as well. And we graph this, we're going to shoot another ray because we want all the values that are greater than 2. So that's our first function here. Our next example. Once again, we have two functions. We have when x plus 3 when x is less than or equal to negative 1, and 2x when x is greater than negative 1 and less than or equal to 1. So we need to have our two t-tables. First one, all the values that are less than negative 1. So negative 1, negative 2, and negative 3. So just plug these values into your function. So negative 1 plus 3 gives us 2, negative 2 plus 3 gives us 1, and then negative 3 plus 3 gives us 0. Now we want all the values are less than or equal to negative 1, so that's a closed circle, closed, and closed as well. Now on this one, we want all the values between negative 1 and positive 1. So we want to find a good number in between, which obviously would be 0 is the easiest. Then we plug these in. So 2 and negative 1 gives us a negative 2, 2 and 0 gives us 0, and 2 and 1 gives us a positive 2. Now since the value of x is greater than negative 1, we have an open circle, closed here, and since less than or equal to 1, closed circle as well. So then we just graph this again. So negative 1, positive 2, closed circle, negative 2, 1, closed circle, and negative 3, 0, closed circle. And then all the values are less than or equal to negative 1, so draw your function. Then we have negative 1, positive 2, we have an open circle, 0, 0, and 1, 2. And then this is just going to be a segment because we only have the values between negative 1 and 1. And that's our second example. Now let's look at our last one. Now this one comes with three functions inside. Right here we have an absolute value, so we need to remember about the vertex and the shape of this. Now over here our interval's absolute value of x is less than 3. Since this is an and compound, remember negative 3 is less than x, which is less than 3. So we're going to go ahead and draw three t-tables. So the first one, all the values that are less than or equal to negative 3. So negative 3, negative 4, negative 5. And once again, since y equals 4, we're just going to have 4 for all of these points. Now, since it's less than or equal to, we have a closed circle, closed as well, and closed as well. Now in this one, negative 3 and between 3 are 2 points. We need to find a good middle one. The best thing to do is you need to include the vertex if the vertex is included with these points. So on this one, our vertex is 1, 0, which is between these two numbers, so make sure you include it. This way you can figure out where the point of your absolute value function hits. So then we just plug these numbers in. So negative 3 minus 1 gives us the absolute value of negative 4, which is a positive 4. Then 3 minus 1 is 2, and absolute value of 2 is 2. So now we're going to have an open circle on -3 because it's greater than -3, close at our vertex, and then open again because x is less than 3. And then our last function. So we want all the values of x that are greater than 3. So 3, 4, and 5. Then we plug these in. So we got -3 plus 7 gives us 4. -4 plus 7 gives us 3. And -5 plus 7 gives us 2. So we want all the values that are greater than 3. So an open circle, and these will all be included. And then we just graph these. So we have -3, positive 4. And we want all the values that are less than or equal to -3, so we shoot our function out this way. So now our next one, we have -3, 4, we have an open circle. Just go ahead and just draw a circle over this. 1, 0, so that's our vertex. And then 3, 2, we have another open circle. So we're going to make our absolute value function here. Then our last one, we got 3, 4, it's another open circle. 4, 3, and 5, 2. We want all the values that are greater than 3, so we're going to shoot our function out this way. And that's it.